Welcome to the Complete Engineering Podcast, brought to you by the University of Nebraska-Lincoln College of Engineering.
Hey, welcome back to the podcast. I'm your host, Karl Vogel, and today we're going to take a closer look at one of the fastest growing trends in fashion and engineering. It's known as wearable technology. It's something that's been around as long as humans have sought to make their work easier and more efficient. Back 500 or so years ago, it was the introduction of the watch as a necklace. And nowadays, we have smartwatches. We have devices that count our steps, track calories that we burn, monitor our heart rates and blood pressure. We have virtual reality glasses, helmets, and goggles that train soldiers and athletes and gamers, and medical devices that collect all kinds of health information to treat and diagnose diseases, not just in humans, but in pets and livestock as well. But can wearable technology do more? And we have today researchers from the Chemical Engineering Department, Alyssa Grube, a doctoral student, and Kaitlin McKenzie, a junior. Welcome to the podcast.
Thanks for having us here.
Yeah, thanks for being a part of it. I'm going to start just a general question for both of you. Beyond smartwatches and video gaming devices, what other amazing things are being done in the field of wearable technology right now?
So some of the things that I've seen are, first, the smart glasses as a more advanced version, if that makes sense, to take pictures, messaging, in addition to video. I've also seen some more technology-inspired dresses that have like additional appendages that can actually move independently. That's more of a kind of high fashion thing still, instead of something more accessible to everyday people, in addition to what you said about the smartwatches.
And working in the wearable technology field here, what kinds of things could or maybe should wearable technology be doing for humans or others that it's not doing right now?
So what we're kind of working on is trying to develop technology that will be able to collect energy from waste body heat and movement to charge wearable devices, to make those wearable devices even more convenient, because right now the most popular method of charging them with lithium-ion batteries is not very environmentally friendly, and it's not very convenient because you still need to plug them into something else to charge them back up. And that takes a while. But if you were wearing something that could do that while you were using it, then it would extend the usable time of those devices.
Yeah, I know from my own experience, my smartphone tends to run low on battery after about 5 or 6 hours. And sometimes that's it would be handy to be able to plug it into my shirt and have it charge up. What was the inspiration for the project you're working on, and tell us a little bit more about this project?
Yeah, so back when I first started in 2020 on my PhD program, Dr. Bavarian, my PhD advisor, told me to basically that my PhD project would be in supercapacitors, and essentially told me go look at the literature and see what's been done, because with a PhD you need to do something new. So after reading a lot of research papers about supercapacitors to try and get some fundamental information and understanding, I noticed that textile supercapacitors was something that was on the newer side. So then I started reading more about that, and then eventually I started noticing a pattern that everyone was using pretty much exclusively cotton or polyester or nylon. Nobody was touching wool. So then after that, I kind of compiled everything and then took it to Dr. Rand and said, I think we should do this, but with wool, because I haven't found anything using wool from a sheep. And so then that's how we kind of started on this project. We first started with cotton to kind of to troubleshoot everything, figure out how to actually do the methodology that I've been reading about, and also to get a baseline for comparison before we got wool working. And we're actually the first people to get wool working. So that was pretty exciting. And so that's kind of where this whole thing started kicking off, essentially.
Yeah, and how are you making wool be conductive for electricity? I wouldn't imagine that beyond static electricity that maybe it pulls anything in. How are you making it more conductive?
Yeah, so we're taking a conductive material and we are applying it to the wool. So the conductive material that we're using is referred to as maxines. It's just a very thin conductive material that we can apply to the yarn before knitting it up into electrical circuits. And that conductive material acts kind of like a pigment. So it does stiffen the yarn a little bit, kind of like a graphic t-shirt, if you think about the pigment on the graphic t-shirt. So that's how we make the yarn conductive.
Is that some of the work you're doing, Kaitlin, in the lab, is applying these materials?
Yeah, as of right now, my main job is to help Alyssa out, and that's just basic testing as well as application of what we're doing onto the wool yarn as well as cotton, and comparing and contrasting the differences between the two.
And what's that work like for you? How's that work with what you're learning in your chemical engineering studies?
Yeah, so a lot of the topics kind of collide more with what I've learned in an electrical engineering class that I've been a part of, whereas the synthesis of the maxine that tends to correlate with my chemistry classes. So it kind of takes a lot from like a little bit from each of my classes and then combines them to an actual application of what I'm learning. So electrical concepts of like capacitance, and I'm not going to get into it, but just those electrical components that I learned in class my first few years, I was able to apply to this research project.
Now, did either of you think that at any point in your college careers that you might be onto something that would potentially change the way we live our daily lives? Like, wearable technology is becoming so ubiquitous in society. Everybody's got one. I read a study that 10 years ago, that 1 out of 5 people had some sort of a wearable technological device. And I got to imagine that that's even a higher number now. And the potential for creating clothing that charges your devices is going to change the way that we live. How do you see this innovation changing things for people?
I can see it as essentially making it easier to use the technology that we already rely on, such as cell phones and smartwatches and other wearable tech, because I don't think that that's going to go away, because our entire society, at least in the US and a lot of other places that I've been, really relies on these devices now. So it's not going to go away anytime soon, I don't think. I think it's just going to change to become even more mobile and convenient and sort of integrated into our everyday lives, essentially. And so then I see this technology as making that more possible, because instead of needing to stop somewhere and charge your phone or your smartwatch or whatever, you wouldn't need to do that anymore. You could just keep going with it, essentially.
Or college students having to keep their computers plugged in when they're taking notes. And I think this is something that's definitely going to revolutionize things, and it's going to open up opportunities in fields like chemical engineering. And a lot of people might think it's strange that electrical type of work is being done by chemical engineers. Alyssa, how did you come to be working on electricity and focusing on that in this? You kind of have a background with fashion, don't you?
Yeah, so my background from high school and a little bit in undergrad, because of my hobbies and everything, is a lot in making clothing. So I did a lot of knitting already. I've actually been knitting since I was about 11. And then I've been sewing since undergrad, because I asked my grandmother to teach me how to sew.
Yeah, we're going to show a few of the items that you've made while we're talking here.
Yeah, so I asked my grandma to teach me to sew because I was kind of fed up with clothing not fitting me properly. So now if it doesn't fit me properly, it's my fault. And so so I had all of that background and a lot of interest in learning about like the history of fashion and the materials used in fashion. So all of that went into support this research project because I've been hand knitting everything that we've done so far. And then in addition to that, my undergrad background in engineering science and mechanics also gave me a pretty broad understanding of a lot of different engineering disciplines. So that kind of combined to help develop this research project into what we are currently doing today in the lab.
Yeah, and how is this work kind of influencing your idea of what your future is going to be in engineering?
It's kind of changing it, but not really, because in undergrad, I was preparing myself to go to grad school to get a PhD because I would like to eventually go into academia to be the PI of my own lab. I know there's a long way to go for that, but that's kind of what I would like to do. I think it's mostly changing what my specialty would be in, because in my undergrad, I was working more in fuel cell research. So this is still kind of in the same area of green energy. It's just slightly different because I never actually expected to kind of come full circle with designing materials for fashion wear, if that makes sense.
Mhm.
Even if we're still in the very early stages of that. But in a way that's coming full circle, because in high school, before I decided to go into engineering, I actually wanted to be a fashion designer. So, and then that's kind of what set me on the path for engineering, because I started getting more interested in wearable technology and designing the wearable technology that people were experimenting with at the time. And so then that's kind of what set me on the path to here, essentially. So in a way, I didn't actually expect to get here, but at the same time, it is what I had been working towards for a long time.
Yeah, so you've been building to this for quite a while, and you're starting to realize some of the dream a little bit that you
Mhm.
had earlier. But Kaitlin, were you ever dreaming of designing fashionable materials or anything like this? How did you get to be a part of the project?
I'm going to be honest, I don't think I've ever once thought I would be designing fashion materials ever. I'm going to kind of answer that by going a little further back for me. So I kind of originally joined chemical engineering because not only did I like chemistry, I liked math, and then I was good at both of them. So I kind of just smashed them together to come up with chemical engineering, and I've liked it ever since. But I also chose chemical engineering because I enjoy being excited about things. I enjoy unique things. I feel like sometimes I get bored somewhat easily, and
Yeah.
I feel like this is a good degree that kind of there's a little bit of excitement in every single day. Something new always comes up. It's not the same day to day, and I think that's what brought me to research as well, because that's not always the same day to day. There's always something new to look into, and specifically with this research team. I wanted to join this project because I thought it was really unique. I thought it was really interesting. I liked how new it was as well. That really appealed to me, that it's not something that I necessarily heard of. So I wanted to know more about it. But in the end, it really interests me because things that I apply towards my job now is not something that I would have found interesting before. So it was something that made me realize, like, oh, what I just learned in class is really applicable, and was really exciting to be able to apply it. And that, I think, is how I became truly engaged in this lab.
So you have a more of a traditional view of what engineering would be before you started college, and how is working on this project kind of opened up your horizons, I guess you could say, in engineering? What is it you're learning about the future here?
Um, that it kind of made me change. I hope I'm going to answer this all the way. But it made me change my view of where I wanted to go as well. I was thinking just industry, but now I realize that grad school is a possibility because I'm being really engaged in a lab setting. So that's kind of my future, I guess. If you're talking about the future of this project, like what Alyssa was saying, there's a very large area for this to go in. Like, it's still at the beginning stage, so the potential that it has to go places, I think, is really exciting. Did that answer all of your questions?
Yeah, it does. And that kind of leads me into the last part of what I want to talk about here is what's next in the research lab. Obviously, you still got a ways to go with the work on the wool and the conductive material, but is this opening avenues for other things, and where do you see yourself headed along these lines?
Yeah, so we're also going to be exploring other conductive materials to try to work towards creating a longer term stability of the conductive yarns, because the material that we work with lasts about a month. So the material that we work with currently, we think would be best for military expeditions with a set length of time to power the small electronic devices that the soldiers carry with them. We're also working on exploring different conductive materials because we would like to create this for space applications in spacesuits to help power some of the non-vital systems. And I'm defining that as being things that are not directly related to keeping the astronaut alive. And then, so to do that, we want to create yarns that have much longer term stability. And we would also like to explore creating other electrical circuits to try to create a full circuit with yarn. And then on that front, we're also looking forward to getting a knitting machine to make sure that what we're creating in the lab is still applicable in an industrial setting for mass-produced items, because I've been hand knitting the circuits right now, which works for creating individual circuits to troubleshoot and make sure everything is working with those. But it wouldn't really work for an industrial knitting machine. And then it also doesn't show that they would work in tandem together. So the other reason we're excited about a knitting machine is to make a full circuit as a proof of concept to make sure that the whole thing is working.
Definitely. And I wonder, is there any thought of working to someday scale this up and maybe start your own fashion company? And
I am considering it. So that is something that I'm considering, but want to get the PhD first.
All right. Well, perhaps this could be the beginning of a lot of things. And we've got a lot of good things happening here at the College of Engineering. And this is, I think, one of the most exciting avenues that's going on. Alyssa, Kaitlin, thank you for joining us today, and keep in touch and let us know how things are going and what breakthroughs you're going to make.
Yeah, thanks for having us here.
All right, take care. I want to thank everybody who's tuned in to watch, all of the people here on the crew who've helped out. And I want to remind our audience that you can find Nebraska Engineering on social media at Neb Engineering, I believe, on Twitter. And we also want you to check out our YouTube channel. Other podcasts and other videos from the College of Engineering will be available. Everybody have a great day, and we look forward to talking to you all again.
Thank you for listening to the Complete Engineering Podcast. For more information, visit us at engineering.unl.edu.